So our next video in this group is going to be talking about circuits in series and the rules associated with looking at circuits in series. So first, a couple of notes. When we're talking about a series, and we'll look at some pictures here in just a minute, what we need to notice, the key feature is that there's no junctions. So anytime that you're working in a series, you should see no splits. No junctions means they all flow in one straight line. Okay? When we're talking about a circuit that is in series, the current which is the letter I or the units, amps, stay the same the whole time. All right, so this is a big deal because when we get to parallel, which is the counterpart to series, that won't be true. The current will change and something else will stay the same. So I have here a resistor set drawn in series. So I have resistor 1. Whoops, that didn't draw. Try that again. I have resistor 1. I have resistor 2. And I have resistor 3. Now if I wanted to look and find out what the total resistance is across these, or the equivalent resistance, I can simply add them up. All right, so I paused for a minute so that I could write. And now I'll talk and hopefully everything is in sync. I noticed in the last video that we watched that my voice was a little bit out of sync with what I was writing. I'm going to see if that happens again in this video, and if it does, we'll address it. Now, compare that to capacitance. And I have 3 capacitors lined up in series. So, whoa, didn't mean to do that. So I have capacitor 1, capacitor 2, and capacitor 3. If I want to look for my equivalent capacitance, it's a little bit harder. So what we'll find is the equivalent capacitance is going to be 1 over C1 plus 1 over C2 plus 1 over C3, and if there's more you could just keep going with that. And then when you get there, you have to take everything to the negative first power. So another way to look at this that's easier for some people is to write it out like this. Okay, now we are going to practice these in our practice problems, but what this would mean is that we would add up fractions So imagine 1 over 3 and 1 over 5 and 1 over 9, all in the same problem. So I'd have to add up all those fractions first, And then when I get them, I have to take the reciprocal of the answer. So if I got 1 over 17, I would have to take the reciprocal and I'd get 17. All right, so if we go back up and we look here at what we have, the pattern that emerges, looking for a color here, is that resistance grows when we put them in series and capacitance shrinks when we put them in series. So the more resistors we put together in a row, the less electricity is going to manage to get through the wire. The more capacitors, wait, I said that wrong. Nope. The more resistance that we have, the less energy is going to flow. The resistance is going to get bigger. When I put capacitors in a row, the amount of energy that they're going to store is going to get reduced. And the more of them that we have, the less storage we actually have of electricity. Okay, so before we go into trying problems on our own, let's try a problem together. I have an energy source, and attached to that energy source is a string of Christmas lights. So I'm going to draw 5 of them here, but there'll be 50 lights in a row. And each one of them is going to take a little bit of electricity to run. Each one's going to act like a little resistor. So what the question is asking is, what's the potential difference across one bulb when I plug them into a 120 volt outlet? Hang on one sec. All right, so we are looking at, I'm going to switch colors here, Kirchhoff's law. And he says the sum of the potential difference across everything in a circuit has to be canceled out. So I have one positive, I have my energy source, and I have 50 negative bulbs. So 50 bulbs that are acting as resistors. And when I take that 120 and I divide it out 50 times, that means that each bulb has to take out 2.4 volts, so that each one of those subtractions adds up to 120. Not really so hard. So whoops, that was an R that didn't draw with my pen. Okay, so that's our beginning introduction. The application is what we're going to do over the next 4 problems. Say, okay, it's great to see the rules. How do we use them? What does it mean? This video is already 10 minutes long, so I think I'm going to stop with that, and we will pick up with the rules on the next one.